Here we go with another screencast, and you should take out your reference table, turn to page 1, Earth Science Reference Table. You're not really turning to page 1 because, well, page 1's the first page. We're going to be talking about specific heat today, and the denotation or definition of specific heat is the amount of heat required to raise the temperature of 1 gram of that substance by 1 degree Celsius. There's another way to say it. You're basically looking at specific heat is a measure of the resistance a substance has to a change in temperature. The higher the specific heat, the longer it takes to heat up and cool off. The lower the specific heat, the faster it takes to heat up and cool off, which is kind of awkward phrasing on my part. Should say maybe the shorter it takes to heat up and cool off. I was also toying around, by the way, can you see that heat is in red and cool is in blue? That's no mistake, or no coincidence is what I should say. I was going to do heat up in red and cool off in blue. But I just figured you guys might not be ready for that. It might be a little too cray-cray. But I did it already, so you can't put the genie back in the bottle, as they say. So here we go. Taking a look at page 1, specific heats of common materials. You can see that water, liquid water specifically, has the highest specific heat at 4.18 joules per gram times your degrees Celsius. So if you have 1 gram of water and you want to change it by 1 degree Celsius, you would have to add 4.18 joules to that water. Look at poor lead on the bottom. You'd only have to add 0.13 joules per gram to get it to change 1 degree Celsius. Well, what's a joule? Well, last year you might have learned that a Newton meter is a joule, right? That probably doesn't help you either. So in class we'll kind of explain, give you some references for joules to have a better understanding what joules are, but just realize it's a measure of the amount of heat energy. If I take a look at this beach that I own, I forgot where it is though, so I haven't been there in quite some time, or my backyard. And if you went to either of these places during the day, you would probably do the "it's too hot to stand here" barefoot dance on the sand, and then you would go to the water and put your feet in and experience some relief, because the sand here has an awful lot of basalt and granite in it, which has a very low specific heat, and water, liquid water, has a very high specific heat. So the land is going to heat up very, very quickly, but the water won't. So water has a very high specific heat, which is why the sand during the day gets really hot and the water is still relatively cool. If you haven't been to the beach, you probably should remedy that and go. So think about Long Island. If you go to the beach in June, the water will be relatively cool, but the land will get hot during the day, especially on a clear day. The sun's out, the sun's been out for a couple of hours. You know that sand heats up pretty quickly. The sand heats up so quickly because it has a very low specific heat, especially when compared to water. So if we had to organize these objects, the first thing we should do is take out our reference table and use that. Make sure I'm on the selector tool, which I am. And now if I take a look at, let's find liquid water. Liquid water, we know, right over here, has a very high specific heat. Therefore, we would put that on the side of heat slow. What's next on the list? Solid water, which we also know as ice. And then what would be next? Water vapor? Well, that's not there. Dry air is not there. Basalt. Do you see basalt? 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 Nope, no basalt. Finally, granite. So granite would go here. And then what's next? Iron. After that, we have copper. And after that, we have lead. So these are organized based upon what would heat slow, liquid water, solid water, granite, iron, copper, and lead, and what would heat fast. So lead would heat the fastest because it has the lowest specific heat. The next page, we're looking at what's going to cool fast and what's going to cool slowly. Again, that's based upon specific heat. Something with a high specific heat is going to cool slowly. So something like liquid water will cool slowly. Something like lead will cool quickly. Solid water would go over here. Again, I'm basing it upon this list over here. Well, what do you think would be next on the list in terms of cool slow? What would be next to solid water? Take a minute and think about it, and now will me, through brain power, through your psychic ability to move the granite to the right spot. Ooh, I just told you. You willed me to tell you. Your psychic powers are growing quite strong. What would be next then after granite? We would have what? Yeah, do it. Do it with your brain. Concentrate, focus, get me to move it. Wow. Hey, nice job. And finally, that was much, much, much faster. So these are organized based upon what would cool slowly because of a high specific heat and what would cool quickly or fast because of a low specific heat. Now, during the day, what's going to heat up faster. Now this is during the day, that's why the sun is there and the sun is shining in the sky. El Sol brilla en el cielo. If you think about this, and I'll put on a song for you. It's my favorite song and your favorite song to help you concentrate. So while the song's on, think about it. It's good. You're making me choose a pen, which is good. So it's going to heat up faster. And what do we know? Land is going to heat up faster during the day because land has very low specific heat. Now, what if I magically make it night due to some digital wizardry? And now I'll put the song back on. You're going to do the same thing. You're going to will me to circle the correct answer.
Let's make some fruit salad today. It's fun to do. It's a healthy way.
It's my favorite part right now. Okay, so it's going to cool off faster. Cool off. You think? And you are correct if you said land. Land's going to cool off faster because land has a low specific heat. Which brings us to everybody's favorite earth science questions. So which substance has the highest specific heat? Very direct and straight and to the point. And if you look at your reference table, what would be the answer here? What do you think? Will it to happen? Nice job. And what about this one? On a clear summer day, the surface of land is usually warmer than the surface of a nearby body of water because the water, what do you think the answer to that one is? Oh, perhaps you need some music to concentrate? Is that what you're saying? Because you're being hesitant?
Peel your bananas. The second step. Toss in some grapes.
Nice job.
Chop up some apples.
Nice job. And that is the end, sadly, of another screencast. Be prepared to come in school and to possibly apply this information in some logical way. Have yourselves a great day.